Through the endless static of space, a whisper emerged, faint, rhythmic, deliberate. It began as a simple anomaly buried deep within NASA's data archives, a flicker of green light echoing from the void beyond. Mars. Analysts first dismissed it as noise, a cosmic coincidence of radiation and reflection. But as the pattern repeated, perfectly timed, it began to resemble something that nature does not often produce: intention. Subscribe, not just to a channel, but to the endless story of the universe itself. The telescopes that caught it recorded more than light. They recorded behavior. The pulse moved with a grace that defied randomness, bending through the solar wind as though guided by invisible geometry. Each oscillation carried structure, a pattern too organized to be chaos, too subtle to be signal. In the sterile rooms of NASA's data centers, the noise became a heartbeat, and somewhere between fact and impossibility, the line began to blur. For weeks, the pulse remained unannounced, buried beneath layers of classified observation logs. Then, a leak, an internal data stream briefly mirrored to a secure channel used by researchers, revealed coordinates, motion curves, and a designation unknown to the public. The file was small, but its implications vast. It spoke of an object moving through interplanetary space, not from the asteroid belt, not from any mapped trajectory, but from beyond the heliosphere itself. In those numbers lay a paradox. The light curve was natural, yet deliberate. The velocity erratic, yet precise. Every frame of data contradicted what the laws of motion should allow. Something was moving through the solar system that did not fully obey its rules. It seemed to know where it was going. Silence followed. Official channels denied anomalies, even as internal systems scrambled to cross-check readings. NASA's public releases spoke only of routine observational variants, but within closed circles, whispers grew. Scientists who saw the data described a feeling of unease, not because the object was dangerous, but because it was different. Humanity's instruments, for the first time, seemed to capture something that wasn't supposed to exist. Across the distance of space, the faint green pulse continued, steady, deliberate, alive. It drifted through the cold with the stillness of something ancient, reflecting the sunlight in strange, shifting wavelengths. As analysts studied its geometry, they noticed a pattern within its brightness, ratios repeating like design, symmetry within chaos. And then came the name, hidden within the metadata of the leaked file: 3I Atlas, the third known interstellar visitor to enter our solar system. A silent traveler from beyond the stars, carrying with it a question too vast for certainty. No message accompanied its arrival. Only motion, only light, and in that faint emerald rhythm, humanity faced once again the same haunting truth that the universe does not reveal itself through answers, but through silence. In the spring of 2024, beneath the soft hum of the Atlas survey telescopes in Hawaii, a faint green speck appeared on a sequence of sky images, an object moving too swiftly, too precisely, to belong to the familiar architecture of our solar system. The system flagged it as 3I Atlas, the third recorded interstellar object ever to enter our cosmic neighborhood. But, unlike the cold, tumbling rocks that had come before, this one glowed. Its light shimmered, not in reflection, but in emission, a pale emerald radiance pulsing from within, as if the void itself were breathing. At first, the data seemed ordinary, a trajectory, a magnitude, an orbital curve. Yet, when analysts examined the readings, subtle impossibilities emerged. The object's spectrum revealed heat signatures inconsistent with any known comet or asteroid. It was warm to warm, maintaining a stable internal temperature despite the freezing vacuum that surrounded it. The infrared data, later revealed through leaked telemetry, showed localized bursts of plasma discharge, flickers of energy that rippled across its surface in measurable intervals. It behaved like a beacon. Every 11 minutes, its brightness spiked, precisely timed, like the pulse of a rotating transmitter. The rhythm was steady, unwavering, immune to randomness. Astronomers at JPL and the University of Hawaii cross-verified the anomaly. Same interval, same amplitude, same mysterious glow. In raw photometric data, the pattern repeated again and again, a light curve too perfect to dismiss as natural coincidence. The leaked files deepened the mystery. Internal NASA reports, never intended for public release, referenced stable energy bands detected across multiple wavelengths, as if the object were not merely reflecting solar light, but generating its own electromagnetic resonance. Its plasma emissions appeared structured, oscillating in symmetrical patterns. Some researchers noted geometric nodes in the frequency plots, a mathematical consistency found nowhere else in the known catalogue of celestial bodies. As the days passed, its path became clear. 3-1 Atlas was moving toward Mars, not grazing past it by chance, but aligning on a trajectory that placed its closest approach mere millions of kilometers from the planet's orbit. In the leaked emails that surfaced weeks later, one internal message carried a simple but chilling note: stand down on optical follow-up directive from upper management. Several observatories, including those in Chile and Arizona, reported sudden cancellations of scheduled observation windows. Requests for data access were quietly denied. Behind closed doors, debate ignited. Was this a case of overcautious bureaucracy or something else? Some within the agency argued for transparency, insisting the anomaly be made public. Others feared global speculation, the spiraling effect of releasing unverified data. The silence that followed was not scientific, it was human. For those who saw the unfiltered data, awe mingled with unease. It was as though a question had entered the solar system, one too complex to answer, too dangerous to confront. The object remained distant, yet its influence spread through encrypted files, whispered conversations, and sleepless nights inside dimly lit control rooms. 3I Atlas continued its slow, deliberate drift past the red glow of Mars, a ghost of mathematics and plasma weaving through the dark. Its light pulsed on, methodical and unwavering, a silent rhythm echoing through the void. And in that rhythm, humanity was forced to face a truth it had never truly prepared for, that discovery and discretion are not opposites, but twins born from the same fear of what might be found when the universe finally looks back. As the investigation deepened, analysts began cross-referencing the 3I Atlas telemetry with archived observation data from other space-based sensors, the Deep Space Network, the Solar and Heliospheric Observatory, and several infrared arrays that constantly monitor the inner solar system. The comparison exposed additional inconsistencies. The object's acceleration profile didn't match gravitational predictions. It was moving slightly faster than expected when passing through regions where solar radiation pressure should have slowed it down. The variance wasn't large, but it was persistent, a steady discrepancy that pointed toward an unknown source of propulsion or internal energy. Further analysis of spectral data revealed narrowband emissions in the ultraviolet range, faint but measurable, repeating at consistent intervals. These emissions didn't align with common outgassing processes that occur in comets when volatile materials evaporate under solar heat. There were no detectable tails or dust clouds surrounding 3I Atlas, no signs of ejected debris that could explain the thrust-like anomalies. To those who studied the numbers, It behaved less like a passive object and more like a system, a mechanism with internal order. In the cold silence of interplanetary space, where sunlight fades into the deep black, 3I Atlas continued its silent passage, a glowing emerald shard adrift between the orbits of Mars and Jupiter. For most objects born of stone and ice, motion in space is predictable, obedient to the ancient language of gravity, but this one did not behave as it should. Its path wavered subtly at first, then, with measurable defiance, the velocity curve flattened, then rose again, as though something unseen had adjusted its momentum. To the data analysts watching the live telemetry streams, it was the digital equivalent of a pulse, a deliberate correction that no natural rock should make. The algorithms that track non-gravitational acceleration, usually applied to comets, venting gases, couldn't explain it. There was no visible outgassing, no dust trail, no shift in spectral composition that might account for thrust. The numbers indicated a controlled change in speed, small, precise, rhythmic. In the language of orbital dynamics, it was impossible. In the language of speculation, it was deliberate. Weeks later, a second anomaly surfaced. Instruments aboard the Mars Reconnaissance Orbiter detected faint electromagnetic fluctuations in the surrounding plasma as 3I Atlas approached perihelion. The signal was structured, oscillating between fixed intervals, far too coherent to be noise. When cross-referenced with data from Earth-based magnetometers, the pattern aligned perfectly, forming a slow, repeating wave across millions of kilometers. Some described it as a heartbeat, others, more cautiously, as a field resonance. But either way, it was artificial in behavior, if not in origin. Within NASA's Jet Propulsion Laboratory, the findings stirred unease. The leaked briefing, a 38-page document marked Preliminary Non-Gravitational Propulsion Assessment, revealed a phrase that would later ignite endless debate. Observed acceleration events may indicate localized emission of directed energy. To some, it was cautious scientific phrasing. To others, it was a confession, an acknowledgement that 3I Atlas was doing something no natural object should be capable of. Astrophysicists tried to anchor the anomaly in known science. Could asymmetric albedo cause differential solar pressure? Could exotic ices beneath the surface sublimate unevenly, mimicking propulsion? Each hypothesis collapsed under the same problem: consistency. The force vectors were too stable, too aligned, repeating over intervals that implied feedback. The object wasn't reacting to the sun. It was responding to something. Behind closed doors, the conversation darkened. Some analysts proposed that 3I Atlas might be a fragment, a remnant of an engineered structure, perhaps ejected from an ancient system long gone cold. A technological fossil wandering through the stars until captured briefly by our solar system's pull. That theory, however, never made it into the official press release. Instead, it appeared in the margins of an internal memo, stamped with a red seal, classified astrobiology. The existence of that stamp alone said enough. The term astrobiology wasn't applied lightly. It meant that someone, somewhere within the hierarchy, had considered the possibility of intention, that this was not a comet at all, but something constructed, or once constructed by hands or minds unknown. But speculation, especially at that scale, was dangerous. It meant rewriting what humanity thought it knew about its place in the universe. And science, for all its curiosity, has always feared one thing more than uncertainty: confirmation. As the object drifted past the orbit of Mars, its glow dimmed slightly, but the energy bands within its core remained steady. Observatories still tracking it described its light curve as mechanical, rising and falling in intervals too precise to belong to chance. The plasma surrounding it pulsed with a rhythm that mirrored its earlier acceleration events, as if the two phenomena were connected by design. Yet, when journalists asked for updates, NASA spokespeople maintained silence. No new findings, they said, even as internal servers logged hundreds of encrypted data transfers labeled under restricted review. The deeper question, the one no official dared speak aloud, began to echo quietly across observatories and universities. If this was artificial, then where or when did it come from? The stars around us are ancient, their civilizations, if any, long extinguished. Could 3i Atlas be a relic, a wandering envoy from a species that once knew how to move between suns? Or was it something simpler, yet more unsettling, a probe left behind to observe us? Within the silence of its trajectory, there were no answers, only questions reflected in the faint green shimmer of a stone that should not exist. Science, for all its instruments and certainty, found itself staring into an abyss, not of implication, because if 3i Atlas was not alive, it was still behaving as though it remembered something, a command, a purpose, a destination written in equations we have not yet learned to solve. In the end, the mystery did not weaken belief in science. It tested it. For the first time in generations, researchers were forced to confront a truth older than discovery itself, that knowledge does not always comfort. Sometimes it only widens the void. And somewhere within that void, an object still moved, slow and deliberate, as if the cosmos itself were waiting to see whether humanity would dare to look deeper. As more data streamed in, the focus shifted from observation to verification. Research teams across multiple institutions began to audit the raw telemetry, hoping to identify a technical error or calibration fault that could explain the anomalies. The algorithms responsible for tracking 3i Atlas were tested, recalibrated, and cross-verified against other known interstellar objects like Oumuamua and Borisov. Every comparison yielded the same result. The readings were authentic. The acceleration was real. The next phase of inquiry came from the Deep Space Network, whose radio arrays monitored the object for residual emissions. Analysts detected short, intermittent bursts of narrowband radio noise in the S-band range, frequencies typically reserved for communication between probes and mission control. The bursts were weak, but their periodicity matched the object's rotational cycle. When plotted, they produced a repeating harmonic pattern. Nothing in the surrounding space could account for it. Solar wind fluctuations, background cosmic radiation, or interference from terrestrial satellites were systematically ruled out. The emission source was consistent with 3i Atlas itself. At NASA's Goddard Space Flight Center, researchers privately referred to the event as the persistence anomaly. The term described both the endurance of the signal and the refusal of the object to behave like any known body. In subsequent days, data compression protocols were tightened and server logs encrypted. Only a limited number of scientists retained access to the unfiltered telemetry feed. Those who did described its readings as non-random and structured. Meanwhile, independent observatories in Chile, Japan, and Italy confirmed similar results. Optical polarization studies indicated that the reflected light from 3i Atlas wasn't scattering like a natural mineral surface. Instead, the polarization angle was fixed, suggesting a uniform reflective layer, possibly metallic or crystalline in composition. The spectral return curve showed no organic compounds, but did reveal trace emissions resembling ionized xenon or argon, elements commonly used in experimental propulsion systems on Earth. The pattern of acceleration also became clearer. Rather than constant propulsion, it occurred in short bursts, each lasting between 11 and 16 minutes, followed by periods of complete stability. This indicated control, or at least regulation. A fragment from the leaked telemetry report summarized the discovery. Observed thrust events are discrete, measured, and energy, implying optimization. This was the point where official communication diverged from the internal findings. Publicly, NASA referred to the object as a highly reflective interstellar body exhibiting minor non-gravitational forces. Privately, several senior analysts debated the possibility of a self-regulating system, something designed to maintain trajectory within a narrow vector range. The conclusion was left open-ended. No one could confirm intent, but the absence of randomness was undeniable. Parallel inquiries began to surface in the defense sector. NORAD and the US Space Force both requested tracking updates, though neither publicly acknowledged involvement. Classified briefings between NASA and Defense Intelligence cited unresolved anomalies of potential technological interest. The tone had shifted. The event was no longer framed as an astronomical oddity, but as an object of strategic significance. Speculation spread quietly through the astrophysical community. Some researchers proposed that 3I Atlas might represent a form of passive technology, a probe or data capsule using gravitational fields to navigate interstellar space without propulsion. Others suggested it could be a natural relic, containing magnetic materials that responded to solar radiation in an unusually stable way. Both explanations fit portions of the data, but neither addressed the rhythmic energy emissions or sustained velocity corrections. The international scientific response became fragmented. The European Space Agency announced plans to monitor 3I Atlas using the Gaia telescope, but later suspended updates without explanation. The Japan Aerospace Exploration Agency released only a brief note confirming the object's reflectivity patterns before going silent. In the absence of transparency, online communities filled the gap, spreading theories ranging from alien technology to secret government projects. By the time the object passed beyond Mars's orbital plane, the intensity of observation diminished, but not the curiosity. 3I Atlas maintained its steady course toward the outer solar system, still emitting faint magnetic pulses detectable only by the most sensitive instruments. It left no trail, no debris, and no clear explanation. In the months that followed, the academic reports were quietly archived. Peer-reviewed papers were delayed or withdrawn before publication. Only fragments of correspondence, leaked through encrypted channels, preserved the debate. They revealed a rare moment in modern science, not confusion, but hesitation. The data spoke clearly, yet the implications were too large to fit within accepted frameworks. For now, 3I Atlas remained classified in practical terms, observed but not discussed, catalogued but not understood. The scientific process had reached its limit, constrained not by technology, but by uncertainty itself. Each unanswered question added another layer to the mystery, reinforcing the same uncomfortable truth: something out there had behaved in ways no known natural object should, and the world's best instruments had recorded it with perfect clarity. It began not with a telescope, but with a sequence of numbers hidden among thousands of nightly observations from Atlas. The asteroid terrestrial impact last alert system, built to protect Earth by mapping the near-Earth sky. Atlas scans the heavens for motion, tracking objects that might one day cross our planet's path. On an unremarkable night in 2024, it recorded a flicker, faint, elongated, and moving faster than any known asteroid within range. To the system, it was just another point of light. To the few who reviewed the raw data later, it was something else entirely. The coordinates placed the source near the edge of Mars's orbital corridor, its trajectory slightly inclined, its albedo unusually high. Objects from the interstellar medium are typically dark, ancient rocks scarred by radiation and dust. But this one gleamed. The algorithm tagged it for reclassification, noting reflectivity inconsistent with any carbonaceous or silicate body. Beneath its spectral curve, a small anomaly appeared, a signature that mirrored the reflective index of polished alloys. The file was logged, time-stamped, and quietly stored. In the weeks that followed, the data passed through routine calibration pipelines. Analysts ran standard verification tests, yet the readings held steady. When cross-matched with Pan-STARRS and NEO-EYES, both systems returned confirmation. The same coordinates, the same reflective anomaly. And then, inexplicably, both observatories stopped reporting updates on that coordinate block. Within 24 hours, NASA's Deep Space Network retracted its scheduled observation window without explanation. The silence was not overt. It was procedural. Observers simply found the field marked restricted. Then came the leak. An anonymous upload appeared on a small FTP mirror used by amateur astronomers for data exchange. A compressed archive labeled Atlas_OBJ3I. It contained frame sequences, light curves, and internal telemetry logs not found in any public release. The files circulated briefly among independent researchers before the archive disappeared, its mirrors scrubbed within hours. Yet fragments of its data, saved by those who had downloaded early, began to re-emerge on encrypted channels. Within them, one string of metadata drew attention: 3I Atlas, confidential. Among the astronomers who saw the data, none spoke publicly, but several reached out to science communicators and researchers unaffiliated with NASA. Their accounts matched. Each described the same set of anomalies: internal heat signatures inconsistent with simple solar heating, a slow rotational pulse suggesting regulated motion, and plasma discharges at frequencies no natural comet or asteroid had ever displayed. One referred to it as an engineered resonance. Another simply called it wrong. Behind the scenes, the institutions remained quiet. Atlas logs were reissued with revisions, and internal memos urged caution regarding unauthorized data handling. Pan-STARRS denied having tracked the same object, despite cross-reference data that proved otherwise. NEO-EYES' official response stated only that thermal readings were inconclusive. For the public, the story ended before it began. But for those who had seen the numbers firsthand, the question deepened, not about what the object was, but why its existence seemed to vanish in real time. The deeper one followed the trail. The more deliberate the silence appeared. The sequence of retractions, the sudden policy updates, and the identical phrasing across agencies all hinted at orchestration. It wasn't a denial rooted in confusion. It was management of discovery. Observatories that depended on NASA for funding avoided mention entirely, while smaller institutions were reminded of protocols regarding sensitive space data. No one officially confirmed the existence of 3I Atlas, yet the leak had already ensured it could not be erased completely as the story spread. Across the quiet corners of the scientific community, a pattern emerged: the tension between truth and control. For centuries, astronomy had thrived on openness, on the collective pursuit of the unknown. But now, the sky itself seemed partitioned by jurisdiction. The instruments were public. The discoveries were not. Data that once belonged to humanity had become proprietary, guarded not by nations, but by necessity, the fear that knowledge too disruptive might destabilize the narrative of what is natural and what is not. And so, in the aftermath of the Atlas data leak, A final question lingered, one not of science, but of philosophy. If truth can be measured, captured, and archived, does it belong to those who observe it, or to those who decide what is seen? Somewhere, within the quiet corridors of data centers and observatories, that question remains unanswered. The light from 3i Atlas continues its journey outward, unbothered by secrecy, carrying within it the same paradox that started it all, a reflection too bright to be ignored, and too dangerous to be acknowledged. The retrieval of the original Atlas observation logs became a focus for several independent research groups. Using archived public feeds, data scientists reconstructed partial sky maps from the nights surrounding the event. The coordinates aligned precisely with the original timestamps, confirming that the anomaly wasn't a sensor malfunction or a transient cosmic ray. The frames showed a consistent light curve across multiple exposures, proving that the object maintained visibility long enough for accurate tracking. Once isolated, analysts ran statistical analysis on the photometric data. The albedo values exceeded those typical of interstellar debris by nearly 60%. A surface with that level of reflectivity would require either freshly exposed ice or a material capable of mirroring light efficiently, such as metallic compounds. Yet, no sublimation tails, dust emissions, or gas ejections were recorded, key indicators of an icy body. The object was dry, hard, and thermally stable. It was neither a comet nor an asteroid by standard classification. Attention then shifted to its thermal profile. The data suggested an internal heat gradient, not from external solar radiation, but from a residual source within. Thermal modeling demonstrated that if 3i Atlas were composed entirely of rock or metal, the measured temperature would not match expected solar heating values at its distance from the sun. The emission pattern hinted at controlled energy retention, something capable of regulating or distributing internal heat. Several researchers proposed a layered structure, perhaps a shell or composite casing designed to shield inner material. At the same time, observatories in the southern hemisphere reported brief visual confirmations that matched the object's calculated trajectory. These observations were never published in peer-reviewed journals. Most were submitted as internal memos or preprints that later disappeared from institutional archives. In one case, a telescope technician noted that after filing a report on 3i Atlas, the observation server underwent scheduled maintenance, and access logs for that period were wiped. The timing of the data leak became another anomaly in itself. Metadata from the FTP archive indicated that the upload occurred within 12 hours of the object's official reclassification. This meant the leak originated from within the data chain before information reached public channels. Several experts concluded that the source was likely internal, someone with access to NASA's restricted observation network. Attempts to trace the origin led to dead ends, anonymous routing paths, temporary servers, and proxy nodes spread across multiple countries. Whoever released the data had planned it meticulously, leaving no digital footprint. The aftermath extended beyond scientific circles. Policy divisions within NASA reviewed data sharing protocols, leading to the quiet suspension of public access for certain telescope feeds. In internal documentation, 3i Atlas was labeled anomalous object, data verification pending, a classification that effectively froze discussion. Communication with affiliated observatories shifted to closed channels. Requests for raw data were redirected or delayed indefinitely by mid-year. What remained of the Atlas data leak circulated among small communities of astrophysicists and data archivists who continued to study it independently. Cross-comparison between the leaked files and legitimate Atlas records showed minimal discrepancies, strengthening the case for authenticity. The leaked telemetry, when processed with updated orbital models, revealed a trajectory correction that coincided with the period of missing public data. That correction could only be explained by an external force or internal propulsion, both options unprecedented for an interstellar object. Privately, a handful of analysts continued their investigations using open-source tools and residual sky data. They discovered micro-variations in brightness occurring at regular intervals, implying rotation or signal modulation. Though inconclusive, the pattern was too consistent to be dismissed. It indicated that the object was not tumbling randomly, but rotating in a measured rhythm. In official correspondence, NASA maintained its stance. 3I Atlas represents a natural, interstellar body exhibiting unique but explainable physical properties. However, that explanation was never detailed publicly, and no follow-up papers appeared in scientific literature. For the broader astronomical community, the case simply ended there. What lingered instead was the procedural trail, the silence, the restrictions, the missing reports, all pointing to a moment when information itself became more valuable than discovery. The data had been captured, verified, and contained. But beyond institutional boundaries, the numbers continued to circulate, examined by those unwilling to accept closure without understanding. In the end, 3.1 Atlas remained a verified object with unverified nature. The systems that found it moved on to new alerts and near-Earth monitoring. Yet within the archives, buried beneath layers of access restrictions, its original files still existed, immutable evidence of something that entered the solar system, glowed brighter than it should have, and left more questions than any official report was willing to answer within the quiet corridors of NASA's research divisions. A fracture began to form. It wasn't a disagreement over the data itself. The numbers were undeniable, but over what those numbers meant and who deserved to see them. When 3I Atlas appeared on internal briefings, it arrived not as an astronomical triumph, but as a problem to be managed. Officially, it was an object of interest, under evaluation. Unofficially, it was the spark that ignited one of the most divisive ethical conflicts in the agency's modern history. On one side stood the scientists, the astronomers, data analysts, and project engineers who had dedicated their lives to exploration. For them, discovery was not meant to be hidden. The pursuit of knowledge was a contract with humanity itself, to observe, to share, and to understand. They believed the public had the right to know that something extraordinary had entered the solar system, something that challenged the boundaries of natural celestial behavior. Yet across the table sat administrators and policy officials, invoking national security protocols and interagency agreements. They spoke of stability, of potential misinterpretation, of the dangers of mass speculation. In a recorded meeting later leaked to an independent journalist, a senior official was heard saying, "The data is not the problem, the narrative is. Once this gets out, we lose control of it." That statement captured the essence of the conflict. Discovery had collided with perception. The scientists who had first confirmed the anomalous readings were suddenly bound by silence, instructed to sign updated non-disclosure agreements under the pretext of data verification. For many, it felt like a betrayal of purpose to find something wondrous, only to be forbidden from acknowledging it. Whistleblowers began to emerge quietly in the months that followed. They described late-night conferences where internal emails were deleted and data servers were reclassified under higher security tiers. They spoke of researchers reassigned to unrelated projects without explanation, and of internal directives marked classified. Astrobiology, one astrophysicist, speaking under anonymity, described the mood as a cold kind of fear, not of danger, but of consequence. The fear that acknowledging the impossible might unravel the delicate fabric of scientific order itself. For those closest to the discovery, the psychological weight became harder to bear. To study something that defied categorization and remain silent about it was to exist in two realities at once: the private truth of knowing and the public facade of denial. Conversations about 3I Atlas continued only in encrypted messages or whispered exchanges at conferences. The excitement of discovery was replaced by isolation. Some researchers withdrew from the field entirely, citing exhaustion and disillusionment. One described it as the loneliest form of curiosity imaginable. The ethical debate extended beyond NASA's walls. Within academic circles, questions arose about who truly owns the frontiers of knowledge. Is discovery a privilege of institutions or a right of the species that seeks to understand its universe? Philosophers of science pointed to a growing tension between transparency and control, the belief that too much truth, too quickly, could destabilize societal or political order. Yet others countered that suppressing knowledge was the greater threat. For ignorance, too, has consequences. The deeper conflict was not logistical but human. Discovery has always been a reflection of those who make it equal parts wonder and fear. The same minds capable of mapping distant galaxies are also bound by the same instincts that protect, conceal, and rationalize. Within NASA, this paradox played out quietly but profoundly. The debate over 3I Atlas was not about what it was, but what it meant, and whether humanity was ready to confront that meaning. Over time, internal dissent gave way to resignation. The official narrative held firm: 3I Atlas remained classified as a natural interstellar body with unusual photometric behavior. The scientists who had pushed for openness moved on to other missions, but traces of their conflict lingered in unfiled papers, in encrypted archives, in the cautious wording of public statements that said less than they revealed. And beneath all of it lay the silence, not the silence of space, but of people. The silence of discovery withheld, of truth confined to data centers and private memories. A silence heavy enough to shape the future of how science itself chooses to speak. Because sometimes humanity's first reaction to the extraordinary is not celebration, it is containment. Not because it lacks curiosity, but because it fears what curiosity might uncover. In that quiet pause between knowledge and disclosure, the story of 3I Atlas stopped being about an object. It became about humanity, its fragility, its caution, and its uneasy relationship with the unknown. As internal tensions persisted, the reality inside NASA and its associated research centers became bureaucratic rather than dramatic. Layers of procedural control were added. Every mention of 3I Atlas required authorization codes. Any external collaboration request involving data from the object was automatically flagged for administrative review. The process became so cumbersome that most researchers simply stopped asking. Access logs showed that even senior scientists had their viewing permissions revoked without explanation. The official line was data integrity assurance. Unofficially, it was information quarantine. The atmosphere changed from scientific curiosity to quiet compliance. Meetings that once centered on data interpretation shifted to risk management. Public affairs officers drafted press statements preemptively, each vetted by multiple departments to ensure consistency. Even the language used internally began to soften. Anomaly replaced phenomenon. Fluctuation replaced signal. The object was still under study, but its mystery had been administratively diluted. This was the most effective form of censorship, not erasure, but redefinition. For many involved, frustration turned into resignation. Several key researchers transferred to other divisions: climate modeling, satellite systems, propulsion studies, anything that would distance them from the bureaucratic tension surrounding 3i Atlas. Yet, through private channels, the conversation continued. Some began documenting everything they could before files disappeared behind restricted layers. Copies of spectrographic readings, trajectory simulations, and energy output graphs surfaced months later through encrypted networks used by independent astronomers. These documents painted a picture that was consistent, detailed, and deeply concerning. The readings didn't match any known form of cometary or asteroid reflection. Meanwhile, journalists and amateur researchers noticed the sudden drop in NASA's public data feeds. Observation logs that once updated hourly went silent for days. When asked about the delay, agency spokespeople cited server maintenance and revised calibration protocols. The explanation was technically valid but incomplete. Behind closed doors, administrators debated how long the situation could be controlled before speculation filled the void. Predictably, speculation did. Online forums exploded with theories ranging from technological malfunction to extraterrestrial origin. The more the agency withheld, the faster the narrative escaped their grasp. Outside NASA, the event began influencing international relations among observatories. The European Space Agency quietly suspended a joint observation project, citing data access inconsistencies. Several academic institutions in Japan and South Korea filed formal requests for transparency, emphasizing the importance of collaborative science. These requests were received but not answered. For the first time in decades, space research, once a symbol of global cooperation, was being fragmented by secrecy. Inside the agency, the moral strain deepened. Some employees began documenting their experiences anonymously, describing the psychological toll of working under silence. One described the office atmosphere as sterile, like everyone is waiting for someone else to break first. Others feared career repercussions. Those under active non-disclosure agreements faced periodic compliance checks and mandatory rebriefings. The message was clear. Discussing 3i Atlas, even in speculative terms, could end a career instantly by this point. 3.1. Atlas had transitioned from an astronomical discovery to a management problem. Every decision was filtered through committees, legal reviews, and communication teams. The object itself had not changed. Only the human reaction to it had. While telescopes continued to collect readings, those readings were increasingly detached from open scientific discussion. The distance between discovery and disclosure widened until it became structural. The agency had effectively built a firewall between truth and acknowledgement. In the end, the object drifted beyond its closest pass, leaving behind a trail of classified files and unanswered questions. Scientists who once debated its composition were reassigned. Projects tied to its observation were quietly retired. Official documentation summarized it as an anomalous interstellar object, behavior consistent with natural parameters pending further study. The phrase was technically accurate, but intentionally incomplete. It said nothing of the divisions it created, the careers it derailed, or the moral weight it imposed on those who saw too much and could say nothing. What remained was a subdued acceptance. The discovery had not been lost, it had been contained. The lesson inside NASA became implicit. Not every revelation was meant for the public domain. Whether that decision preserved order or stifled progress depended on who you asked. But one truth lingered: unspoken science, for all its pursuit of transparency, still answers to human fear before it answers to knowledge. It began quietly, not with the roar of discovery, but with the faint flicker of light, a rhythm noticed only by those who still look up. Amateur astronomers, scattered across continents, began reporting something strange near the orbit of Mars. Irregular flashes, subtle yet persistent, pulsing against the black backdrop of space. At first, they were dismissed as imaging errors, cosmic rays striking sensors, or reflections from satellites. But patterns have gravity, not physical, but psychological, and soon the pattern began to pull minds toward it. The flashes returned at intervals too distinct to ignore, too deliberate to explain away. In online communities, the reports multiplied. Threads filled with grainy stills and magnified frames showing a faint green luminescence in motion. Some saw it as proof of a magnetic anomaly, others as evidence of experimental propulsion tests hidden from the public eye. A few dared to say the word that scientists avoided: artificial. For most, it was just noise in the cosmic data stream. Yet among that noise, there was order, or at least the illusion of it. And that illusion was enough to ignite curiosity. Data analysts, outside institutional science, joined the chase. Using open-source telescopic feeds, they began to triangulate the flashes, comparing timestamps across observatories in Hawaii, Chile, and South Africa. The triangulation formed a path that wasn't smooth or elliptical like a comet's, but jittered, almost as if the object corrected itself mid-flight. The motion wasn't random drift under gravity. It was erratic, but controlled. Not mechanical, perhaps, but responsive. Something was influencing it, either an unseen force, or a mechanism built to resist natural decay. This was when skepticism sharpened. Professionals from established observatories stepped in, cautioning against premature conclusions. They noted that solar wind, turbulence, magnetic flux near Mars, and lens aberrations could all produce visual irregularities. Yet their caution only fueled the opposite reaction: belief. Every denial felt like confirmation that something extraordinary was being hidden. The online narrative split, half scientific rigor, half mythology in motion. What united both was the same question: if not natural, then what? Reports from independent monitoring stations, including those feeding into NASA's Deep Space Network, noted subtle magnetic distortions corresponding to the timing of the optical flashes. The readings were faint but correlated, a pattern of oscillation that suggested an active field, not merely a passive response to solar radiation. This observation alone challenged natural explanations. No known, non-metallic object could sustain such a magnetic variation without rotation-induced interference or internal energy dynamics. The question emerging among analysts was simple but profound: what was driving it? Computational models attempted to simulate the behavior. Some proposed that solar-wind interaction with an unusually conductive surface could create localized plasma discharges, producing the rhythmic flicker. Others pointed out inconsistencies. The timing remained too regular, and the observed deceleration too selective. A naturally occurring body under solar and gravitational influence should slow uniformly. This object did not. It appeared to alter velocity relative to the Sun in controlled increments. As if adjusting course, private aerospace firms quietly joined the review process. Engineers specializing in propulsion mechanics recognized patterns resembling pulsed plasma propulsion, a concept used in experimental satellites to maintain orbital stability using ionized bursts of xenon or argon. But no human-made craft of that design had been launched along a trajectory intersecting Mars, and none were capable of sustaining flight without telemetry links. The object was far too distant to be a stray probe, and far too stable to be an unregulated fragment. As the investigation deepened, data privacy increased. Servers containing observation logs were mirrored into closed research networks. NASA and ESA teams cited data integrity concerns, restricting external access while citing security protocols. This move reignited online debate. If the object were truly just an unusual rock, why the secrecy? Independent scientists petitioned for transparency, but official channels remained silent, neither confirming nor denying the authenticity of leaked data. Silence became its own form of confirmation. In academic circles, discussion shifted from what it was to how it behaved. Orbital analysts compared its movement to previous interstellar visitors, Oumuamua and Borisov, but 3I Atlas did not conform. Its path appeared reactive to gravitational gradients rather than fully determined by them. A minority within the astrophysics community proposed non-gravitational propulsion events, implying that outgassing or sublimation might produce thrust-like motion. Yet the energy signatures did not match cometary gas release, and thermal imaging revealed no heat plumes typical of sublimatio. As weeks passed, new data trickled from observatories in Japan, Italy, and the Canary Islands. Each confirmed the same rhythmic luminescence, each measured consistent pulse intervals, and each failed to identify a natural mechanism behind it. The phenomenon hovered in an interpretive limbo, too structured to be random, too anomalous to classify. Every new observation seemed to confirm the same paradox, that 3I Atlas moved, not as a drifting relic of cosmic debris, but as an entity responding to forces beyond current understanding. Researchers began cross-referencing its behavior with solar activity cycles, magnetosphere fluctuations, and cosmic ray interference. Nothing correlated. The signal's persistence defied environmental explanation. In peer circles, some admitted privately that they had begun to doubt natural causation altogether. Others, more cautious, insisted that unrecognized physics might still account for the anomaly. Perhaps electromagnetic coupling or yet undiscovered interactions between charged dust and solar plasma. The uncertainty itself became the story. By the time public attention faded, the scientific world remained divided. What had begun as a faint glimmer in the night sky had become a data point that refused classification. Theories accumulated faster than evidence. The object's rhythmic flashes continued, silent and unreachable, orbiting beyond Mars, carrying with them the weight of human inference. It neither confirmed nor denied its nature, only moved, predictably unpredictable, a point of light that reminded every observer of the boundaries still, unbroken in the search for understanding in the cold stillness of interplanetary space. 3.1. Atlas began to defy the very equations that had once defined motion. Its trajectory, first a quiet arc along the predictable influence of Mars gravity, shifted in ways that defied explanation. It accelerated, not with the push of solar radiation, nor the drift of inertia, but in defiance of both. The solar wind, streaming outward from the sun at over 400 kilometers per second, should have pushed it gently away. Instead, sensors recorded it moving against that force, not drifting, but maneuvering, as if guided by intention. For months, astronomers debated in encrypted channels and private conferences. Theories sprouted like seeds in darkness, speculative, desperate, brilliant. Some invoked quantum propulsion, the hypothetical use of vacuum fluctuations to generate thrust without fuel. Others proposed photonic pressure inversion, a theoretical reaction where specific reflective geometries could create differential acceleration against solar photons. A third camp revived plasma drive hypotheses, speculating that internal magnetic confinement could ionize and eject particles for propulsion. None of these explanations satisfied the data. The energy required was astronomical. The precision, inhuman, the leaked spectrographic data only deepened the confusion. Embedded within the light signature of 3I Atlas were trace readings of isotopes unknown to any terrestrial registry. Ratios of nickel to iron, unlike those found in natural meteorites. Bands corresponding to rare ionized states of silicon and tungsten, materials seen only in laboratory plasma reactors. These results were quietly shared among select research divisions before being withdrawn, redacted, or replaced in official records. The revised files listed the anomaly as signal contamination, an unconvincing footnote for a discovery that violated the periodic calm of astrophysics. Within NASA, tension grew. The public statements described 3I Atlas as a hyperbolic interstellar object under observation, but internally, enthusiasm bordered on obsession. Transcripts from technical meetings, later leaked, captured a tone rarely heard in such institutions, excitement mixed with disbelief. "If this data holds," one engineer was heard saying, "we're looking at something not bound by known mechanics." Another voice, more cautious, replied, "Then we must redefine what we mean by known." The transcripts ended there, followed by a classified header, marking further discussion restricted to a new internal group, Atlas Special Review. Outside official circles, the scientific community began fracturing along ideological lines. Traditional physicists demanded restraint, calling for data verification, error analysis, and caution against sensationalism. Others, including a small group of theoretical cosmologists, argued that suppression of inquiry was itself unscientific. They pointed to the consistency of the acceleration pattern, the spectral data, and the object's apparent trajectory stabilization near Mars' orbital corridor as evidence that something unprecedented was occurring. For them, the anomaly was not an error but a revelation. As observation continued, a new phenomenon emerged. The object's apparent energy field fluctuated in rhythmic intervals, as though oscillating between states of emission and absorption. The pattern repeated every 21 minutes, consistent for over 100 recorded cycles. No known natural process could maintain such stable periodicity in an unbound interstellar fragment. The readings forced analysts to confront an uncomfortable question. Was this an artifact of observation or a signature of control? The boundary between science and speculation began to blur. Quantum physicists proposed that 3I Atlas might be interacting with the sun's electromagnetic field in ways unaccounted for by classical mechanics. Perhaps, they suggested, it exploited gradients in space-time curvature, producing motion through the manipulation of quantum vacuum energy. Others went further, invoking the possibility of non-localized propulsion, motion derived from quantum entanglement across scales. Such theories were dismissed by mainstream panels, yet they persisted in academic margins, whispered in late-night discussions where careers could not be risked. The emotional undercurrent within the research community became unmistakable. It was not fear of the unknown, but fear of irrelevance, that the universe had shown a mechanism beyond the limits of current understanding. To some, 3I Atlas was a mirror reflecting the boundaries of human intellect. To others, it was evidence that those boundaries were meant to be broken. As days turned into weeks, official channels fell silent again. Data once public disappeared from servers, replaced by maintenance notices and broken links. Amateur astronomers who continued to track the object found themselves working in isolation, their findings ignored by the institutions they had once admired. But still, the numbers remained. Acceleration against resistance, energy without source, motion without decay. At the edge of comprehension, science stood divided, between belief and disbelief, between observation and interpretation, between the comfort of known laws and the discomfort of their failure. 3I Atlas continued on its path, silent and deliberate, untouched by debate. Its presence reminded humanity of an ancient truth that discovery often begins not with understanding, but with surrender. The universe had whispered something new, and for the first time in a long while, science did not know how to answer. In the following months, the anomaly became the subject of cross-institutional collaboration. Teams from the European Space Agency, JAXA, and the Jet Propulsion Laboratory reprocessed the available raw telemetry, isolating the object's motion vector from gravitational influences. The data confirmed what had been quietly suspected. 3I Atlas was accelerating at intervals too structured to be random. The acceleration was not continuous, but incremental, resembling the pulsed propulsion sequences seen in advanced ion thruster technology. Each pulse corresponded with minor spectral shifts, brief moments of elevated ultraviolet emission followed by These emissions lasted fractions of a second, yet they occurred with precision over several consecutive days. The anomaly raised practical questions that went beyond theoretical speculation. If the object was self-propelled, it required an internal energy source. Estimating the energy demands revealed figures far beyond those achievable by chemical reactions or solar absorption alone. Even if it possessed a reflective surface of perfect efficiency, solar radiation could not explain the sustained acceleration observed. Researchers modeled alternative explanations: internal decay, heat, electromagnetic coupling, or reactive plasma propulsion. None matched the observed pattern. The emitted light carried wavelengths inconsistent with simple heat radiation, suggesting directed energy release rather than passive emission. The discovery placed physics at an impasse. Classical Newtonian mechanics could describe the motion but not the cause. General relativity predicted gravitational effects that were present but insufficient to account for the observed thrust. The anomalies seemed to operate between frameworks, as if exploiting an interaction not yet mathematically defined. Specialists in quantum field theory examined the possibility of exotic matter, substances with negative mass that would move opposite to applied force. Though purely theoretical, negative mass particles had long been discussed in academic circles for their potential use in warp field or reactionless propulsion systems. Yet no evidence had ever indicated their natural existence. 3.1 Atlas now challenged that certainty as internal debate intensified. NASA's communications department released a single-page statement reaffirming that no evidence suggests the object is of artificial origin. The release offered no data, no comparison, and no reference to the leaked reports already circulating among researchers. For many, the denial reinforced rather than diminished suspicion. The gap between what was said publicly and what was being studied privately widened into silence. Within that silence, the scientific community found itself confronting an uncomfortable parallel. The same tension that followed Oumuamua in 2017, when unexplained acceleration forced the reconsideration of interstellar mechanics. Independent researchers turned to archived radio telescope data, hoping to detect emissions associated with electromagnetic propulsion. Some observatories found transient narrowband signals coinciding with the object's position, but signal-to-noise ratios were too low for verification. Statistically, the readings could be explained by background interference. Still, the timing corresponded to precisely to ignore. Private research groups began running their own spectral analysis pipelines, comparing readings from Atlas Pansters and the Very Large Array. The consensus that emerged was subtle but consistent. The object's emissions followed no known natural template. In academic discussions, the focus gradually shifted from proof to implication. If 3I Atlas operated through non-gravitational propulsion, the principle behind it would redefine the limits of interstellar travel. a system capable of maintaining controlled acceleration across astronomical distances implied mastery over energy efficiency on a scale humanity had not achieved. Physicists began to ask a more profound question, not what the object was, but what it represented about the nature of matter and energy. Meanwhile, the object's motion continued with silent consistency. No radio communication, no signal modulation, no detectable transmission, only light and movement. The lack of communication paradoxically reinforced the idea of intent. Its behavior was too ordered for randomness, yet too restrained for outreach. Observers described it as an equation without a variable, a mechanism that operated according to logic invisible to human understanding. By the time its trajectory began to curve outward from Mars' orbital plane, the excitement had shifted to a quiet unease. The anomaly had survived every attempt at explanation. Its measured acceleration remained small but persistent, and every new observation confirmed that it continued to operate independently of gravitational prediction. For the scientific world, it was both an achievement and a frustration, proof that, even with the most advanced sensors and the most intricate models, nature could still produce behavior that eluded comprehension. 3I Atlas became a data point carved into uncertainty, a reminder that science, for all its precision, still functioned within the boundaries of what could be observed, not necessarily what could exist. And in that realization, the object's significance expanded beyond its trajectory. It stood as evidence of a larger truth, that the universe still possessed mechanisms, unrecorded in its own equations. In the calm after speculation, science reaches for the language it knows best: numbers, models, and equations. When the strange green flare of 3I Atlas first burned across the solar recorders, NASA's initial statement came without hesitation: a fragmented interstellar comet exhibiting volatile-driven jets. It was the kind of explanation designed to restore order, a reminder that even in the presence of the unknown, there are rules, thermodynamics, chemistry, gravity, and that those rules still apply. In this narrative, the object was no mystery at all. It was ice and dust, shaped by distance and light, reacting predictably under the heat of a nearby star. As it crossed the heliosphere, solar radiation would have begun to sublimate frozen gases trapped within its fractured core: carbon dioxide, ammonia, methane, perhaps even magnesium compounds deep beneath the crust. These pockets of trapped volatiles, exposed by rotational stress, would erupt in powerful jets. Each release of vapor would behave like a microscopic thruster, altering its path by fractions of a degree, a push here, a drift there. Small, cumulative deviations mistaken for intelligent control, the equations of motion were rewritten with care, compensating for outgassing, angular momentum, and asymmetric torque. In simulation, the numbers could fit. If the object's shape were highly irregular, a flattened ellipsoid, much like the earlier interstellar visitor known as Oumuamua, then the observed acceleration might emerge as a natural outcome of uneven jetting. It was not propulsion, they said, only physics misunderstood by distance. The comparison to Oumuamua was inevitable. That first messenger from the void had also defied prediction, accelerating slightly as it moved away from the sun. The explanation, then, had been similar: sublimation of volatiles invisible to our instruments. Yet no coma, no visible trail of gas had ever been seen. The mystery lingered. Years later, 3I Atlas seemed to repeat the same defiance, but on a brighter, louder scale, glowing with the spectral signature of plasma, its emerald light pulsing like a heartbeat. Spectrographs, recorded wavelengths matching excited carbon atoms and magnesium vapors, both known to emit in the green range when energized by ultraviolet radiation. Laboratory models could recreate the color, but not the persistence. For an object so small and distant, the glow was unnervingly strong, steady rather than flickering. Some physicists proposed that the plasma might be sustained by a thin magnetic sheath, interacting with the solar wind to produce continuous excitation. It was, in theory, possible, though such stability had never been documented in any known cometary body. Still, mainstream astronomy prefers probability over wonder. Anomalies are not evidence of the extraordinary, only evidence of incomplete data. The orbital mechanics teams traced every parameter: perihelion distance, eccentricity, inclination, mapping them against gravitational influences from Mars and Jupiter. Small deviations were reclassified as statistical noise. Others were smoothed into the elegant curves of Newtonian expectation. In the margins of the reports, the numbers lined up neatly, as if tidying away the unease. But beneath the technical papers and peer-reviewed caution, a quiet tension persisted. The models could explain motion, yet not light. The spectral data could explain composition, yet not behavior. Every rational answer left a residue, a gap between theory and observation. And in that gap, something human began to stir, the same discomfort that haunted the study of our models, the same reluctance to say we don't know. For scientists, the comfort of rationality is not denial. It is a necessary shelter. It gives form to the chaos, allowing curiosity to function without fear. When faced with phenomena that border on the impossible, reason becomes the anchor, the one tool that prevents imagination from dissolving into myth. And yet, sometimes, that same reason can become a blindfold. The story of 3I, Atlas, at least in this chapter of its observation, remains one of balance between what can be calculated and what must simply be witnessed. The official reports close with measured restraint. No evidence of artificial activity. Non-gravitational drift likely due to volatile emission. The words are simple, sterile, precise, but behind them lies a quiet confession. For all the equations, for all the spectral graphs and orbital plots, there is still something in the data that refuses to be explained away. In that refusal, perhaps lies the real significance of 3I, Atlas, not as proof of alien design, nor as an error in measurement, but as a mirror held up to the limits of human understanding. Rationality, for all its strength, is a fragile lens. It gives us order, it gives us comfort, but beyond its reach, the universe still whispers in languages we have not yet learned to speak. The debate over 3I Atlas continued through countless conferences, private calls, and closed-room panels. In the years since humanity began tracking interstellar objects, each new visitor had stretched the boundaries of interpretation, but none had created such unease within the data itself. The object's trajectory, first assumed to be hyperbolic, appeared to shift with precision too deliberate for pure randomness. When analysts compared its path across weeks of observation, they found corrections minute, consistent adjustments that countered solar pressure more effectively than any known comet jet model could account for. Teams at the Jet Propulsion Laboratory ran simulations with varied assumptions. Changes in albedo, rotational axis, thermal inertia. Even when pushed to extremes, the models still could not align perfectly with observation. The difference was small, perhaps less than 1% of total motion, but significant enough to demand explanation. Some scientists quietly acknowledged that they were dealing with an object behaving as if it knew how to resist drag. Publicly, however, the official tone remained careful. NASA emphasized the importance of statistical uncertainty. They reminded the world that outgassing jets could behave asymmetrically. The fragments of ice could break free in unpredictable bursts, producing thrust-like effects. At press briefings, the language was carefully neutral. Unusual, inconsistent, requires further study. To the casual listener, these words suggested nothing beyond normal research caution. But within the scientific community, they carried weight. They meant that even the best minds could not make the numbers behave. In parallel, European observatories joined the effort. The European Space Agency's Gaia mission provided new parallax measurements, refining the object's path with microsecond precision. The data confirmed acceleration inconsistent with gravity alone. Independent studies from Japan and Canada supported the findings, each suggesting that sublimation alone could not sustain the observed velocity past Mars' orbit. Yet no team dared to assert an alternative. Every paper concluded with the same phrase: further data required. Attention turned to composition. Infrared analysis revealed an energy distribution unlike typical cometary profiles. It hinted at surface materials with unusually high reflectivity, possibly metallic or crystalline in structure. The brightness curve suggested a body less than 500 meters wide, rotating at a rate that remained surprisingly stable. No known tumbling motion, no chaotic spin. It rotated as if balanced, as if designed for equilibrium in vacuum. Chemically, the emission spectra deepened the mystery. Excited carbon lines alone could not explain the persistent green radiation. Traces of magnesium and oxygen appeared, but at ratios inconsistent with any natural meteorite found in the solar record. There was even faint evidence of ionized silicon, a component rarely sustained in open space without a continuous energy source. When researchers attempted to reproduce these conditions in laboratory vacuum chambers, their models decayed within minutes. 3.1 Atlas had maintained its glow for weeks. The discussion gradually shifted from what the object was to what it represented. To some, it was a wake-up call, proof that humanity's models of cosmic motion were incomplete. To others, it was an opportunity to rethink assumptions about material strength and electromagnetic interaction in interstellar travel. A minority proposed that 3I Atlas could be a natural byproduct of exotic astrophysical environments, perhaps ejected from the vicinity of a neutron star, its structure altered by intense radiation before being flung into interstellar space. Each hypothesis faced resistance. There were no observations of similar bodies, no precedent, no way to verify without direct sampling. And so, as the data accumulated, the explanations began to blur. What remained was not certainty, but a spectrum of possibilities, each one slightly plausible, each one slightly wrong. Within academic circles, some began to refer to it not as a comet or asteroid, but simply as the object, a neutral term, devoid of implication. It was easier to categorize it as an anomaly than to accept the deeper implication that the laws of motion themselves might have exceptions. As weeks turned into months, the mystery grew quieter. The media moved on. Funding shifted to more immediate missions. Mars, sample return, Europa Clipper, the Artemis program. But among the small network of astrophysicists who continued to track 3I Atlas, the silence only made the anomaly more unsettling. The object had passed beyond the orbit of Jupiter, still faintly emitting, still accelerating just slightly beyond prediction. For mainstream science, the case closed not with revelation, but with fatigue. Papers were filed, data archived, conclusions drawn in the safety of probability, yet in the deep background of official reports, the unanswered questions remained, tucked behind layers of qualified language and controlled confidence. In truth, the story of 3I Atlas never ended with discovery. It ended with endurance, the endurance of uncertainty. the acceptance that even with our telescopes, our mathematics, and our faith in reason, there are still forces that refuse to be named. It was not a failure of science, but a reminder of its boundary, the thin, trembling edge where understanding gives way to the vastness beyond, and where even the most rational mind must pause before admitting the possibility that the universe still holds its secrets intact. In the quiet hours between observation cycles, when telescopes rested and data servers hummed in solitude, a different kind of narrative began to emerge, one that science could not formally endorse, but could not fully silence either. Behind encrypted forums and anonymous uploads, a single theory kept resurfacing, whispered by those who refused to believe. Coincidence could account for everything observed in 3I. Atlas. The idea was simple, yet unsettling. What if it wasn't natural at all? The so-called artificial origin hypothesis first gained traction within small academic circles, referencing the work of Avi Loeb and his controversial Project Galileo, an initiative devoted to searching for evidence of extraterrestrial technology using open scientific methods. Loeb had once argued that Oumuamua anomalous acceleration could have been due to artificial means-a-light sail, perhaps, or a fragment of a larger construct designed to harness stellar radiation. His critics dismissed the idea as speculative fiction cloaked in mathematics, yet his reasoning remained grounded in physics. If nature could not explain an object's motion, he argued, perhaps technology could. When 3I Atlas exhibited a similar defiance of known forces, those echoes returned with renewed force. The leaked files only deepened that suspicion. Within one of the redacted NASA archives, now circulated through obscure data mirrors, a single frame showed what appeared to be deliberate rotation. The angle of the object shifted, slightly consistent, not with random tumbling, but with controlled orientation, as though adjusting itself in response to gravitational vectors or solar radiation. The frame's authenticity was never verified. Official agencies denied its existence altogether, yet its mere appearance brief, undeniable, was enough to reignite a global fascination. Fringe physicists proposed explanations that stretched the boundaries of credibility, but not of imagination. Some invoked the concept of von Neumann probe self-replicating machines theorized to traverse galaxies, collecting data or seeding intelligence. Others pointed to plasma-based entities, forms of organized energy theorized to exist within magnetospheres or nebula environments, capable of maintaining coherence through electromagnetic feedback. If such beings or constructs existed, they might not be mechanical or biological as humanity understood life, but something in between, between physics and consciousness. Even within the speculative spectrum, there were attempts to preserve reason. Papers on Arxiv, tagged under hypothetical propulsion systems, discussed non-gravitational motion through plasma sheath manipulation or localized magnetic field oscillations. These weren't wild fantasies, they were extrapolations of principles already observed in laboratory, plasma confinement experiments. But extending those principles to a celestial body hundreds of meters wide was, by all conventional standards, impossible, unless, of course, someone or something had long ago mastered it. Parallel to the scientific conversation ran a psychological one. Why did humanity so desperately want this object to be other? Was it a yearning for contact, or a mirror held up to its loneliness? From the dawn of civilization, the sky had been a canvas for projection. Gods, omens, messengers, all born from humanity's need to assign meaning to what it could not control. The belief that 3I Atlas might be artificial followed that same ancient impulse. The idea that intelligence could exist elsewhere and leave behind something tangible satisfied a hunger deeper than curiosity. It offered reflection, It offered companionship across the void. Among those studying the leaked imagery, one recurring phrase appeared in chat transcripts and archived emails: controlled descent toward Mars. It was speculation built on faint telemetry, perhaps misinterpreted, perhaps not. The object's orientation, when charted over several weeks, suggested an alignment toward the Martian plane, not an impact course, but a deliberate vector adjustment. The data could have been noise, random drift, or calibration error, but to those who wanted to believe, it resembled intention. At first, the notion of directed motion seemed absurd. Yet, when researchers replayed historical observations of other interstellar visitors, Oumuamua, Borisov, they noticed subtle patterns in deceleration and vector correction, small but consistent deviations. It was as if these travelers, each on their own journey, shared a faint signature on echo of design. Of course, mainstream institutions dismissed the idea. The very suggestion of control implied agency, and agency implied intelligence. That single leap from anomaly to intention was one that traditional science could not take without evidence beyond doubt. And yet, in the absence of proof, humanity's imagination filled the void with elegance. Perhaps, as some philosophers suggested, the purpose of such mysteries was not to reveal the existence of others, but to remind us of ourselves, to expose the boundaries of our certainty. Every unexplained object, every fragment of data that refused to conform, was a reflection of the human condition, inquisitive, restless, forever searching for order in chaos. As 3I, Atlas drifted farther into the outer reaches of the solar system. Fading from visible range, its story did not end. It dissolved into conversation, into theory, art, fear, and longing. It became less an object of science and more a vessel of meaning, carrying with it a question older than reason. Are we the first, or merely the latest, to look up and wonder? In the end, perhaps the mystery was never about what 3I Atlas truly was. Perhaps it was about why humanity needed it to be more. Because in the vast emptiness of space, the greatest discovery might not be an alien signal, or a forgotten machine, but the realization that the search itself is what makes a species truly alive. Even after the debate settled into academic archives and the public, fascination faded from headlines. 3I Atlas continued to occupy an uncomfortable space between data and myth. It existed as an unresolved equation, a celestial remainder that resisted classification. The more scientists tried to fit its behavior into the framework of known physics, the more the numbers contradicted one another. A pattern of acceleration inconsistent with sublimation, a thermal signature that failed to decay, a magnetic field that oscillated beyond what natural rotation could produce. Each inconsistency, on its own, could be dismissed. Together, they formed a portrait that refused to vanish. In research institutions, work continued under quiet classification. Teams in California, Hawaii, and Madrid analyzed residual signals from archived observation data, using machine learning to refine trajectory simulations. Their findings suggested that 3I Atlas had undergone at least 3 instances of non-gravitational course alteration. Each shift was too subtle for immediate detection, yet statistically significant when compiled over time. The variations aligned closely with solar flux patterns, if the object responded not to gravity but to energy density. The conclusion drawn in private papers was careful, unknown reactive coupling to solar radiation. But within closed-door discussions, the wording was less restrained. The question wasn't if it reacted, but why. Some of the most striking data came not from visual instruments, but from radio arrays. During its closest approach to Mars, an anomalous low-frequency signal was briefly detected across multiple independent observatories. The readings were faint, repeating every few hours, and located within a narrow electromagnetic band not typically associated with natural plasma emissions. To some, it was interference artifact noise generated by overlapping datasets. To others, it was the first trace of intentional output. No source could be confirmed, and the signal was never captured again. But the timing matched precisely with the object's rotational period calculated from photometric observations. Within weeks, that dataset was retracted. Official statements described it as instrumental crosstalk. Still, the files circulated in informal networks, encrypted copies, mirrored backups, and fragments stitched together by citizen analysts. Amateur groups around the world began correlating their own data, cross-referencing open-source telescope archives. They found faint corroborations of the same frequency window, though no definitive pattern. The effort itself became a symbol of defiance against institutional opacity. Knowledge, they argued, should not be hidden because it made science uncomfortable. Meanwhile, theoretical models continued to evolve. Some physicists proposed that 3I Atlas might be a remnant of a larger interstellar body, one that had undergone technological modification in the distant past. Its behavior, under this model, could represent a passive form of energy storage or stabilization, an ancient artifact still obeying forgotten design parameters. Others proposed an entirely natural mechanism, trapped magnetic domains interacting with solar plasma, creating a feedback loop that mimicked controlled motion. These competing explanations revealed not just scientific uncertainty, but the limits of human perception. The data could be interpreted either way, and the truth remained hidden behind the veil of distance. NASA's silence, while officially pragmatic, deepened public skepticism. When internal communications leaked describing behavioral anomalies inconsistent with cometary activity, they fueled another wave of speculation. Some claimed a cover-up. Others saw caution, a reluctance to ignite unwarranted panic over phenomena still poorly understood. Within the halls of science, there was quiet frustration. The principles of transparency clashed with the obligations of security. What was being protected? The public from fear or institutions from doubt? By the following year, 3I Atlas had faded beyond direct observation, now only traceable through its mathematical shadow set of orbital coordinates drifting toward interstellar darkness. Yet, despite its absence, the discourse it sparked continued to evolve. Conferences debated not the object itself, but the implications it carried. Could interstellar objects be messages, relics, or even probes from extinct civilizations? Was intelligence a property limited to biology, or could it exist in forms unrecognizable to human senses? The deeper the investigation went, the more it revealed about human limits. The need for closure, the discomfort with uncertainty, the instinct to categorize. Every attempt to explain 3I Atlas became a reflection of humanity's approach to the unknown. To label something artificial or natural was not just classification, it was an act of containment, a way to reduce infinite possibility into manageable meaning. Eventually, the question lost its urgency. The object had moved on, beyond radar, beyond speculation. But its imprint remained in the collective mind of the scientific community. It served as a quiet reminder that discovery often precedes understanding, and that understanding itself may never arrive fully in the end. 3I Atlas left behind no message, no traceable signal, no physical sample to study. What it left was a paradox, an enduring uncertainty that blurred the line between science and mystery. It demonstrated that not all discoveries illuminate. Some only cast deeper shadows. And in those shadows, humanity confronts its own reflection, a species reaching outward, searching for meaning. and finding, in the silence of the cosmos, a mirror that reflects its most persistent question, whether it is truly alone, or simply too early in its understanding to know otherwise. Across the quiet landscapes of the world, Issei observed, where night is a vocation and silence is a form of speech, a quiet movement began. It was not announced, nor coordinated through official channels. It was something quieter, shared curiosity threaded through encrypted messages, late-night calculations, and the faint glow of monitor screens tracking coordinates buried in old data. The mystery of 3I Atlas had not ended with its disappearance. It had only deepened, becoming something like a scientific ghost, visible only in fragments of data and in the questions it refused to answer. International telescopes, once devoted to cataloguing asteroids and near-Earth objects, began subtly adjusting their priorities. The Atlas Network in Hawaii, the Pan-STARRS Array atop Helioclab, and even the European Southern Observatory redirected portions of their observation schedules officially to study interstellar transients. Unofficially, they were searching for a pulse, somewhere beyond Mars' shadow. Faint readings continued to appear at irregular intervals, a green-tinted frequency spike, identical in wavelength to the emission once attributed to 3I Atlas. Too weak to confirm, too specific to ignore, the trail of observation had turned into an exercise in reconstruction. Artificial intelligence models, trained on the original trajectory data, began simulating possible paths based on solar radiation, magnetic flux, and gravitational resonance. None of the simulations aligned perfectly. Each model, no matter how refined, diverged by fractions of degrees after several months. The margin of error was small, but it meant everything. The object's last confirmed position no longer matched the laws that governed celestial drift. Somewhere in the data, something was missing, variable no one could identify. Within NASA's own infrastructure, interest in interstellar bodies persisted under other banners. Missions like DART and OSIRIS-REx served as official fronts for planetary defense and asteroid sample collection. Their results made public, their objectives clear. But within internal channels, certain datasets, those concerning thermal anomalies and magnetic irregularities, were quietly withheld from open archives. The reasons given were procedural, instrument calibration errors, data uncertainty, or classified under review. Yet, for those who had studied the 3I Atlas leak, the pattern felt familiar. Information that once reached the public without friction now vanished behind institutional caution. In academic circles, the absence of open data became its own form of evidence. A growing number of independent researchers, freelance astrophysicists, data scientists, and observatory hobbyists formed informal networks dedicated to the pursuit of the object's trail. They shared spectrographs, time-stamped logs, and machine learning filters built from open-source repositories. For them, the pursuit had evolved from scientific curiosity into a kind of shared vigil. To find 3I Atlas, again, was to reclaim an unanswered question, one that had been buried beneath layers of official restraint. Some of these independent efforts yielded faint results. A handful of telescopes, equipped with high-sensitivity CCD cameras, reported momentary flashes, transient signals that matched the spectral hue of the object's recorded emission, but they never appeared twice from the same coordinates. Each signal was followed by silence, like a transmission from something drifting in and out of reach. The object, if it still existed, was either moving beyond measurable range or had gone dormant, its once bright energy signature collapsing into invisibility. Meanwhile, simulations expanded to include non-traditional hypotheses. Some teams integrated variables, accounting for magnetic propulsion or plasma field interaction. Others modeled the possibility of photonic sail effects, akin to theoretical concepts in solar sailing technology. The idea that 3I Atlas could be using solar energy to maneuver intentionally or not was no longer confined to speculative fiction. It was a line of inquiry published in cautious academic language, framed as unidentified acceleration mechanisms. Each model, though incomplete, brought the same conclusion. Whatever it was, it behaved as if guided by principles not fully understood by present science. In private conferences, scientists debated the value of chasing an object that might never be seen again. For some, it was a matter of principle proof that observation should persist until certainty was achieved. For others, it was an emotional struggle. The object represented something larger than data, symbol of how little humanity still understood about its cosmic surroundings. For every confirmed detection, 1,000 uncertainties remained, each one whispering of how vast, how fundamentally unknowable the universe could be. Late at night, in labs and offices half-lit by monitor glow, the human dimension of the mystery came into focus. Scientists who had once spoken confidently about orbital mechanics now hesitated before their own equations. They had followed the path of something that should not exist as it did. And now, in the absence of confirmation, they faced the quiet weight of incompletion. The pursuit had shown them not only the limits of instruments, but the limits of comprehension itself. By the time the last faint pulse disappeared from radio archives, the pursuit had slowed. Observatories returned to their regular schedules. AI models archived their incomplete outputs, and the shared channels grew quiet. Yet, somewhere in the back rooms of research centers and private chat threads among astronomers, the question still lingered, not as a headline, but as a low hum of unresolved thought in the final analyses. 3.1 Atlas had become less an object and more an idea, an emblem of the threshold between what can be measured and what must be imagined. Its green signature had faded from view, its trajectory lost to the void, but its presence endured in the minds of those who had witnessed its brief defiance of expectation. And, as the last data streams tapered into silence, the scientists who remained understood the deeper truth that the universe does not always speak in patterns or proofs. Sometimes it leaves behind impossible anomalies that invite humanity to keep listening. Long after the signal is gone, as months turned into years, 3.1 Atlas transitioned from an active subject of observation to a historical enigma catalogued in mission archives and university databases. Yet, despite official closure, traces of its story continued to resurface within classified networks and encrypted scientific correspondence. The search had become less visible but not entirely abandoned. Small research teams, some publicly funded, others operating through anonymous grant, continued to cross-check data from sky surveys, looking for correlations that standard models had overlooked. It was no longer about rediscovery, but about understanding what its brief appearance had revealed about interstellar dynamics and detection limits. One of the continuing puzzles centered on its acceleration anomaly. Conventional models predicted that an object of its composition and estimated mass should have slowed down after its closest approach to the Sun. Instead, faint trajectory data implied an irregular acceleration event, similar to what had been observed in 2017 with 1I, Oumuamua. The comparison was unavoidable. NASA's Jet Propulsion Laboratory maintained that minor outgassing or sublimation could account for the effect, even without visible cometary trails. But others argued that both events, Oumuamua and 3.1 Atlas, showed consistent deviations not explainable by known physics alone. They pointed to subtle patterns in trajectory curvature that hinted at controlled vectoring rather than random expulsion of material. At the European Space Operations Center, Internal memoranda proposed new approaches to detect non-gravitational acceleration among small interstellar objects. Advanced tracking algorithms, derived from machine learning pipelines originally developed for exoplanet detection, were retooled to process near-Sun flyby data. The intent was to identify anomalies early before they vanished beyond reach. This effort merged civilian and defense sectors, blending astronomical precision with satellite-level tracking technology. Officially, it was labeled an early warning initiative. Unofficially, it was a continuation of what 3I Atlas had begun, an attempt to prepare for the possibility that such objects might not be random visitors. Elsewhere, the Vera C. Rubin Observatory in Chile, nearing full operational capacity, was expected to change the scale of the search entirely. Its Legacy Survey of Space and Time, LSST, would map the entire visible sky every few nights, generating petabytes of high-resolution data. 4 researchers still tracing 3I Atlas's faint pulse. This was the next hope. The observatory's imaging depth and frequency could finally reveal whether the object or others like it still drifted within detection range. As the simulations ran, AI systems continued refining potential trajectories. MODELING, gravitational interactions that could have deflected the object toward the outer solar regions. By the end of the decade, the object's signal had vanished entirely from all known archives. No further detections were reported, no new data confirmed. What remained were equations, simulations, and archived transmissions, digital trail of a cosmic encounter that lasted only weeks but reshaped a generation of inquiry. The silence that followed was not defeat, but transition. Science had not lost the trail. It had merely reached the boundary of its current understanding. Beyond that horizon, 3I Atlas continued somewhere in the dark, indifferent and unreachable, leaving behind a legacy defined not by its presence, but by the questions it forced humanity to ask. When the signal faded and the last telescope turned away, a strange quiet followed, not the silence of space, but of human contemplation. For years, data had been streaming in light curves, spectrographs, orbital plots. Now there was only stillness, the void left by an object that had crossed our solar system like a question without an answer. The scientists who once chased its path found themselves staring at screens filled with empty coordinates, their instruments listening to a sky that had already forgotten. The search had ended, but the echo remained, a whisper of something that had come from nowhere, obeyed no rule, and then returned to the dark. Throughout history, the universe has left humanity such absences, footprints on the edge of perception. Every time the cosmos shows something inexplicable, the response is almost ritualistic. The data becomes myth. The unknown becomes meaning. From comets once feared as omens to signals mistaken for messages, the pattern endures. What we cannot explain, we redefine in the language of belief. And so, as 3I Atlas slipped beyond the reach of any telescope, it began a second life, not as a scientific entry, but as a story. Some saw in it the hand of alien engineering, others a mirror of human curiosity itself, a fragment of cosmic memory, just passing through, but beneath speculation and wonder, a quieter truth persisted. Science is not only a search for answers, it is a measure of how far uncertainty can be tolerated. The moment 3I Atlas defied explanation, it exposed the fragility of what is called knowledge, the precision of mathematics, the authority of institutions, the stability of truth, all trembled under the weight of one anomaly. NASA's public calm masked internal disquiet. Universities debated, forums speculated, and leaked data became modern scripture for those drawn to mystery. It was a reminder that even in an age of advanced technology and global transparency, the boundary between discovery and doubt remains paper-thin. The object's green pulse, now lost in interstellar distance, had once illuminated that boundary. It forced humanity to look not only outward but inward, to question why the unknown feels so unbearable unless it carries meaning. Perhaps that is why every anomaly becomes more than data. It becomes a reflection of human longing, to be observed, to be understood, to belong to something vast and purposeful. The mystery of 3I Atlas was less about what it was than about what it revealed in us. A persistent refusal to accept that the universe might be indifferent. In quiet observatories and dimly lit data centers, the conversations still surface. Astronomers, philosophers, and engineers return to the same coordinates, not to find the object again, but to re-examine the feeling it left behind. The sense that something vast and intelligent had brushed against human awareness and moved on. The possibility that the cosmos itself is aware of its observers, even if only in the way a vast sea registers the ripple of a single wave. And so, the story ends where it began, with a distant light moving against the stars, then vanishing into the black. No signal followed, no confirmation came. What remained was the silence, and within that silence, realization. The universe had not given an answer. It had given a question, one that would outlast the memory of any anomaly in the end. The legacy of 3I Atlas is not found in its composition or trajectory, but in the shift it caused within human perception. It redefined the boundary between science and imagination, between skepticism and faith. It reminded us that every observation is also a reflection, that when humanity gazes into the depths of space, it is seeing not just stars and dust, but the outline of its own need for meaning. Perhaps the real revelation was never in the data. Perhaps the true leak was awareness itself, a breach not in NASA's systems, but in the veil that separates knowledge from wonder. For a fleeting moment, the cosmos had allowed us to see beyond the limits of certainty, and in that glimpse, brief as it was, we remembered why we keep searching, not to find the truth, but to feel once more that the truth might still be out there, waiting. Somewhere in the dark-ass months turned into years, the event known as the Atlas anomaly began to recede into scientific memory. Databases archived the telemetry. Papers that once stirred debate gathered digital dust. Yet, among the scattered communities of astronomers, a quiet persistence endured. Periodically, someone would return to the data, reprocess the infrared signatures, or adjust an orbital simulation, not to prove anything extraordinary, but to ensure nothing had been missed. The pursuit had transformed into a slow, methodical kind of reflection, where precision replaced excitement and patience became the only truth left. The scientific world moved on, as it always does. New missions captured the headlines. Europa Clipper, the Vera Rubin Observatory, updates from the James Webb Telescope. Each of them expanded the map of the possible, yet none erased the unease left. By 3I Atlas, there was an unspoken understanding that something had passed through our solar system behaving in ways not yet accounted for by known physics. And while official reports favored conventional interpretations, every researcher involved understood that the explanations had fit the data only partially, leaving quiet gaps that no one could fill. The questions that remained were not about composition or trajectory, but about process. What happens when discovery collides with uncertainty? At what point does scientific caution become suppression? And when does speculation become necessity? These were not questions that instruments could answer. They belonged to the realm of philosophy, yet they were born from the mathematics of orbital motion. For the scientists who had witnessed the event firsthand, the experience blurred the line between objectivity and awe. It was not faith that lingered, but a kind of intellectual humility, a recognition that even the most precise instruments may only skim the surface of something vastly more complex.